Hi, everybody. I'm Jimmy Judd. I've been a software engineer at Ticketmaster for 22 years now. And yeah, so we're going to talk today about the adventure of automating the VAX. But let me introduce my partner in crime here, or let her introduce herself.
Yes, I am Swetel. I'm an engineering manager at Ticketmaster. Today we're going to talk to you about some interesting things that we've done with our VAX. This is roughly the agenda. What is a VAX? How do you develop and test on one? Setting up for CI. We use Basil. That's tons of fun. And then moving towards CD. Good to go? Right on. Okay, so now that's us. I would like to know about you. Who has ever heard of a VAX? Okay, not everyone. It's an old computer. Did you say who owns a VAX? Does anyone in this room own a VAX? Wow!
That would be cool, actually. Yeah.
I manage this platform. I don't own a hardware VAX, so props.
I can happily admit I watched the last production one get blown to bits.
Literal bits. Okay.
It's online somewhere, yeah.
Are people familiar with like VAX Assembly, Macro 32? Have you seen that before? Some people, okay. What about Pascal? Are you at least familiar with the idea of Pascal? Okay, Basil, the tool Basil. All right. So far, Jimmy,
how do we do on Pascal and assembly?
There were a lot of hands up. Yeah.
Wow, okay.
Yeah.
I'm not going to teach assembly today.
We're all very thankful for that. What about Spinnaker or other CD tools? People familiar with those? So again, lots of hands. We pretty much got lots of hands for all of them except VAX was a little iffy. So what is a VAX? Yay! All right. But what is special about the VAX that we work on? It is emulated. So it's running on just a regular Linux box. It's not a hardware VAX, because who wants to compete with the federal government for parts? Am I right? Yeah.
For used parts at that.
Now, for all you VAX enthusiasts, there's one. The first question I always get is, don't you just love VMS, which is the operating system that most people associate with the VAX? No, in fact, don't love it. Ticketmaster does not use VMS. In fact, they refer to it as VAX made slow. So it was just that in 1976, when this platform was originally written, on a PDP-11, and then moving forward onto the VAX. The PDP-11 was like the predecessor for the VAX. But anyway, when the VAX arrived on the stage, it just couldn't handle some things about the business that Ticketmaster was in, especially things around how many concurrent users you needed and printers. So what did Ticketmaster do? I bet you're asking yourself that. Wrote a custom operating system like everyone does for their mini computer. No? This guy, you've written a custom operating system? Shoot. Yes, so the platform that I manage is a custom operating system, custom VAX operating system running in custom emulation. So, yeah. I think I've alienated basically the whole audience at this point. And with that, I will hand it off to Jimmy to tell you what is it actually like developing on the VAX.
From when I started.
Yes, we're going to hop in the Wayback Machine all the way to
97.
Before I was born. Oh, okay, 97, sure. Yes. Take it away.
You're older than 21? Okay, interesting.
Of course not.
Yeah, so 1997, I get brought into ops and quickly become programming and find that I'm using a CRT, which is a computer that's not a computer. Find that the programming process is Notepad because there aren't any IDEs for VAX assembly code or very, very old Pascal. We had to transfer files to the mainframe using Kermit, which is still very prevalent today in our company. Clients are using Kermit to transfer files, if anybody
Does
even
anyone
knows
know what
that
Kermit is? Okay.
Oh, good. Don't learn it.
Half the audience.
Okay, the other half don't learn it. It's not worthy. The other fun parts about when I started were all of my programming work was done in production. And so all of our testing and user sign-offs and everything was done on the production system, usually just a different program name. It was client program, and so we would run client A. You don't like client A, we write client B. And so that was very, very easy to get addicted to. It was very hard for people to get away from that, especially since it turned the release process into copy client B to client A and you're done. So we're actually trying to get back towards something like that with our CI/CD pipeline, but what was my next slide? Because I finished that one.
Yes, automated testing, when automated testing was introduced into the ecosystem.
Yeah, so we have, over 22 years, the concept of we have to get rid of our ancient VAX has been on executives' lips since day one that I've been there. It's been on a 5-year plan for all 20 years. And this time, we're not actually going to try and rewrite it. But the last time we tried to do it was, we're going all Java. Everything's going Java. Nobody writes anything that isn't Java. The only thing that left over out of that failed project was we had Jenkins tests against our API service that talks to the emulator. That was a beautiful thing, and it only tested the core, very core online functionality, and then it didn't get much support beyond that. And yeah, that's where we landed there, and then we got new leadership.
Yes, so back in the good old days, it's a very manual release process. So in the days that Jamie's talking about, it's extremely, extremely, extremely manual, and there are tons of instances, and each one is custom, and so they're very much pets, not cattle. Then, like Jimmy said, they try this rewrite, it doesn't work, it fails like all the ones previously, just trying to rewrite it from scratch. And so finally, someone says, if we have this transaction engine that's working really well and is very fast, maybe we should just try to incrementally improve that rather than rewriting it, even though it does sound absurd to be running an emulated VAX in the 21st century. So we get funded for this major modernization effort. I feel like I've heard that word a lot today, modernization.
Yep.
And that's when they bring me on board and some other folks, wonderful folks, mainly folks from highly transactional industries like financial services and all that kind of stuff, because selling tickets, you have to sell a lot all at one time. So we launch into this modernization effort, and Jimmy has been kind of the key person, key engineer on a lot of the work around automating these systems. So take it away, requirements.
At least a part of the team, right? The requirements, I actually don't think I was a part of defining this portion. But we knew we wanted to containerize. We knew we wanted to get CI. That was our big target. We want continuous integration. We want automated tests. So we chose to Docker. We chose to run with Helm. We had GitLab already, and so we ran with that. And the other choices of the requirements that we had, we needed to run the VAX on its own and have the API server connect to it, because we have multiple instances of this API server in production, and there would be no way to do good continuous integration tests without having multiple. So we decided not to create a single container and put everything on it, which was an option. But once we had made that decision, we also decided to migrate all of our tests as well. So we needed to get containers that they could use. So building useful containers?
Yes, building useful containers.
Yeah, pick your battles wisely. The biggest stop we had was the automated tests were waiting for us to have containers working of our API server and the emulator. So we just put together binaries into a Docker container and published them. Then we started working on the build pipeline. That actually got our QA person into line, and she was right alongside of us writing her tests. As we worked through the build pipeline, the API server and the emulator were very easy. They're C++ programs. The VAX Assembly and Pascal code was not as easy. And that one turned into roadblock, and we were stopped for a quick minute. Now I will talk about what that roadblock looks like, right?
Developing the Basil build rules.
Right.
Yes.
So they told me, we're going Basil. Okay, go take a look at Basil. Went and took a look at Basil. Figured out, this is the list of requirements, right?
You're talking about what is a Comm File and
Yes.
all of this good jazz.
This is
that how do you use a modern tool like Basil
To
with
make it
something
work,
that is
right.
just a touch less modern?
So I've been given the understanding that a lot of people do know what Comm files are. They're just really simplistic batch files. It just types in commands for you. I do have a slide here that shows a Pascal program. Was that the first one? Mm-hmm. It's a Pascal program and a library. I figured this would be a really good target for me to get building into the CI routine here, or the build process. Now that if you memorize this slide, you can say you know Pascal and write it on your resume, so add that up.
As Judd said yesterday, very marketable skill,
Very.
Macro 32 and Pascal.
And VAX Pascal at that.
Yes,
That's,
yes.
put it on the first line. It'll get you an interview. The next slide is what our Comm file looks like to compile and link, right? We do just simple compile, secondary stage for linking. I know many C programmers might know this. Many C++ programmers may not know that they have a link process, but that's okay. What automation we had in place prior to the modernization effort was expect script. Does anybody know what expect is?
You have about a third to half of the audience.
Okay,
who
that's
may
good,
wanna-
that's good.
Yeah, may want to give a little explanation of expect.
So expect, actually, I'm going to use a lot of technical terms that I don't really know too
We're
much
at a
about.
technical conference, so I
But
think
that's
we're in
okay.
the clear.
So
Yeah.
what expect actually creates a TTY session and will connect to standard in and standard out from pretty much any process you want it to. You tell it to spawn it, or you start it and attach to it. And you can interact using what I call expect scripts. I've heard other people call tickle. I don't know if anybody knows what that is, but yeah, it's, you know, hash exclamation /bin /expect. I don't recommend doing this. So we had a very fluent expect script that ran through a list of Comm files. And that was our check all routine. Is that what's up there?
Yeah.
This is a very short version of what it took to just build the operating system. That leaves out all the ancillary plugin programs that are built using the same compiler and linker, a little over 2,000 of them used. And this was not scalable. It's not supportable. It's not, doesn't give you access to your dependencies in a reasonable way. It's just one big sequential list. I also put in some snippets of the expect script that does it. I cut it apart and put it into one big long stretch here. I would think the key takeaway here is that it's a loop through the Comm file that's typing it in for you and watching for the responses. I did not put the expect regular expressions in here that are watching for responses. That's hideous code. But it does highlight that don't read this code either. It's not. The list of commands is static. There's no flexibility to it. And nobody knows what it means. So we weren't going to use this. We were going to go with Basil. So I wrote down the list of requirements to get a Basil build for VAX. Well, for me, it was just VAX Pascal, but compiling the macro assembly is just as easy. It's the same, different command, same link. I looked through this list of 7 things and looked it over with a couple other people, and they're like, yeah, that's never going to happen. And I went through it again and said, well, actually, I answered every single one of those with 1 line. It was very, very easy. And it turned out a couple of weeks later, I opened, well, not even a couple of weeks. So first, I started out by opening the examples from Basil. They have tutorials in their code. And it showed me what a Basil build file looked like. The C++ one on one side, and what I instantly knew my hello program would look like. VAX library, VAX binary. And given our previous Comm files, we know my VAX library just needs to do a pass and end up with an OBJ file. And my VAX binary needs to do pass link and end up with an executable. Next one is the attributes.
Yep.
Yeah, so I open up a Basil file, a .bzl. It's very Python-ish. It's actually a Python processor, but they call it Skylark. And I see the rules are defined with this header file. Like, that's really all you need to do to define the rule. The key here is the implementation is calling another function. This function is not that difficult either. Next. There's my 7 bullet points alongside of about 50 lines of code.
So you don't have to read this, but we're just trying to illustrate that these things that everyone said, this cannot be done, right? Jimmy gets tons of pushback.
They told me not even try it.
Yeah, he has one-on-one conversations with all of these key people, and then he ends up doing this, and I think it ended up being 41 lines or something like that.
The original, and it only did the Pascal,
so,
but it did compile and link. It's 40 lines. And
on the left is the actual rules, right? And on the right is, these were his list of design targets that he...
Those are the 7 bullet points that were up there.
Yes.
It answers them right there. Yeah, thank you.
And it was in such a short amount of time.
2 weeks.
Yeah.
Yeah, it was a 2-week. And honestly, it should have been a lot shorter, but I'd actually never written any Python before. So I don't know if anybody's worked with Python. It's a really easy language to learn. I recommend it. What was the next slide?
Results.
Yes, so this is what my script spit out. The emulator, I did have to trick the emulator into doing an auto start. And so the very first thing the emulator does is it installs the compiler, installs the linker. That's part of most every instance we have of the emulator. And it runs a default startup file. So I changed that to say, hey, go grab my files and run them, and then close. The Basil rules have one of the attributes, I don't know if you saw it, I didn't call it out, but it is the output. And for a library, you can define many outs. For the binary, you define an out. As long as that file is brought back and put into the right place, the rule will succeed. When the rule fails, I spit out the build log. That's on the right-hand side. It shows everything that just happened. If there was an error, the errors would be splattered across that screen, and you could figure out what happened. So now we are able to build every day brand new VAX code, multiple times a day.
I should just point out, like Jimmy said, there's still not like an IDE for like VAX Assembly. So I apologize for everything being hideous, but I did the best I could. None of us, we just all work in the terminal, right? And so it just is what it is.
Yeah, we're all in the console.
Yeah, so I apologize. The other thing that you don't know about Jimmy is he used to be a designer, so I was extremely stressed when I was making the slides. But anyway, moving right along. Yes, deployments. So we covered CI, and now we're set up.
I did not go over the extreme ugliness of deployments before this.
Yes.
But I can cover a little bit about that now. It was 2 processes. They would get the set of artifacts built by the expect script, and then they would run it through a script on a shared server that would massage and bring any configuration settings that they had changed in production from the previous instance forward and then write checksums about it and manual review. And after that, they would go to the individual boxes and run a secondary script that did more massaging and brought individual systems up in a slow rollout, which is now called canary rollout, right?
And a lot of massaging because each instance was a beautiful little snowflake.
Everyone,
Yeah.
we have 52 pets. We still have 52 pets. We're getting very close to them being one pet, and then they won't be a pet anymore. What we've done with our CI is we post our artifacts after they're built and tested to a shared server. We're using a Maven Nexus server. I'm not real familiar with that. To me, it's just an FTP server that I can curl from. And our dev and QA environments pull down the snapshots, which are posted from master every day. And every day they're started up with a fresh build. Even if there's not a new one, it'll still be the latest that's at master.
There's usually a new one, though.
Yeah, there's usually more, and we usually miss 1 or 2 builds in the dev and QA environment, but they went through the pipeline, so it's fine, because we only reboot the systems once a day in almost every environment. The pre-prod system, it's the similar. It doesn't post every snapshot. It looks for tags. I query GitLab, and I have a little batch file that runs on a cron job. It's about 40 lines. I like that theory there. 40 lines of code should solve everything.
I know, you really gravitate towards that.
I've
really
noticed.
It makes code review
so nice.
fantastic.
My code reviews are done in 10 minutes. Yeah, and it just queries GitLab for new tags, and when a new tag's hit, pulls it down and stages it up for the next reboot for pre-production. And then we have the same thing for production. It's being loaded into the share, and we have pulled out most of their first level of massaging of configurations and have those configurations in our repo and are being deployed now. From there, that's the what's next.
Yeah, I'll just go over a couple things here. So it does go through like a proper pipeline with tests. There's obviously not like a right out of the box test framework for what we got going on over here, but luckily we have a great engineer who was able to find a way to do something. So we have actually a pretty great test suite that runs during that pipeline. And then from there, the snapshots get loaded up into the dev environments where then people can actually use whatever the new software is. And that happens daily. And then the tags, once it's tagged, it'll come up on the next reboot, which is usually each night. But what I think is hilarious is this all just happened in the recent past, right? And the tenure for developers in this area is very long. Like, there's a guy on our team who's worked there 33 years, is that right?
Yeah, 34 now.
Yeah, I mean, there's plenty of people that have worked there longer than Jimmy has worked there. And now the expectation, like if anything goes wrong with this, where the snapshot didn't come up on whatever, like we wake up to this angry barrage of, well, where is this? Well, I mean, this isn't, how can I even work like this, right? I'm like, you do know that, like, a year ago, none of this happened, let alone every single day, right? But now, yeah, and what I think is interesting too is now we have a bunch of people that are like, well, I was really irritated when that didn't happen. And instead of just complaining, they're like, have you thought of doing this, this, and this? And I could try that. It's now people are kind of like, oh, this can be done and it is accessible and I'm just going to participate in that because I don't want to have to wait around for Jimmy or whomever else. Yes, so now what's next besides people's growing expectations?
And their ability to try and shortcut something they don't like. That's one of my pet peeves. So our pipeline is a little slow and it will get faster over time, but that does not mean you need a flag to get past the pipeline. Very frustrating.
So what's next, Jimmy?
So what's next? Well, primarily is going to be, well, we got to finish off the config items and get that last script out of production. But the bigger step is to go to Spinnaker and Kubernetes. Now, we've actually had the VAX running in Kubernetes a couple of different ways, not production. What did you get close to me? I got loud. We also had the pipeline is running in Kubernetes, so the VAX is obviously running in Kubernetes, but it does not live in production that way right now. They're all bare metal machines and data centers in multiple locations, and so we're going to work through Spinnaker and get these loaded up. First, our API server, which will still talk to the on-prem bare metal machines, but then we will get the VAX in there as well. And Spinnaker is our choice. We've looked at a couple of different ones. It just seems to be right fitting for different things that we've learned over time. Probably going to go with a manifest-based, where everybody keeps their own manifest in their own Git repository, and Spinnaker will pull that on its own. And we don't even have to give anybody access to Spinnaker, which would be nice.
If anyone is interested in bare metal Kubernetes with a VAX, we're hiring.
Yeah,
sorry, I had to interrupt you.
There are a
I'm the
couple of
manager.
spots on the team still. We do have our own instance of Kubernetes running now. I'm not going to go into details about that one because we're still building it. It's up and running. It's in production. The other thing that's next is one of the bonuses that comes with Basil is the ability to have a static build box. Starting up the emulator takes a quick second, or 10 or 15. It'd be really nice to enable it to run as a static build box so that it only had to fire up 4 times, and then it would just reuse that 4 times to build all 2,000 artifacts, or it's actually more than that now. What else did we had a third one up there?
Dynamic tool chain. I don't know if you want to, I know this is your favorite.
Does anybody know about dynamic tool chains?
You had 0 hands raised there, Jimmy.
Perfect. So the compiler and linker are written in VAX Assembly code, and they live on my build box. And so if somebody makes a change to the compilers or the linkers, we have to do a manual process to populate them on the build box. And if it's a change of any significance, they have to run it again to get the compiler and linker rebuilt with the new compiler and linker. There is a way to bootstrap all of this to make it happen in real time. I haven't figured out how to do it yet, but I'm gonna.
And it'll be 40 lines.
No, it will. It will very unlikely be 40 lines. Thank you.
Yeah, so we've told you a bunch of really applicable stuff, right? All of you can apply these VAX assembly lessons really easily. No, of course not. But I think there are some things that are generally true, like how were we able to get people bought into this idea? Well, I think it's because as we were going about these things, even though new people came in, right, it was a lot of people that have respect for the history. There's a reason that this VAX is still around. It's because it's the core of the company, and the company is wildly successful, right? So showing that respect for history means that you can get people that have been there for 30 plus years along for the ride. And then we're all babies, and all of your software is a baby too. So at a certain point, we as an industry are going to have to realize that 5 years is not legacy, right? So we're going to have to learn how to evolve things and how to treat, you know, vintage things with the proper respect, right? Or we will lose the ability to, to produce that higher order innovation. So I think, you know, whether or not you think that a VAX should exist in 2020, that's whatever you think, but I have learned so much about how we can mature and evolve this kind of thing, this kind of really critical, highly transactional software. So, yes, thank you so much, and congratulations, Jimmy, on giving his first ever conference talk.
Thank you, thank you.
Yes.
Fantastic, thanks so much.
We did hope for some takeaways here.
Yes, that was it. Oh.
We skipped the takeaways thing,
No,
but
I got it.
one of the takeaways that I want to put out there is when it comes to doing things like this, be fearless and assume success. It's usually very attainable. That's most of the things that people think are too complex probably aren't, and avoid the other side of it where developers always want to make things more complex than they are. I fall for it, and I preach it the most of everybody I work with, and I still fall for it. Yeah. So,
Ready?
Yes.
Fantastic. Thanks very much to Kat and Jimmy. Let's hear it one more time for Kat and Jimmy.
But, so are we ready to begin this portion?
Oh yeah, sure. Let's do it.
So challenges. I think this. We take a look at a lot of the things that are in our infrastructure and the things that we do, and worry about like, oh, it's so complicated, and how do we move forward with this stuff? We want to just throw it all away and use the new Kubernetes stuff rather than the old Terraform stuff that we were using, which we picked up because we threw away with whatever was before that, and repeat ad nauseum, without thinking about how can we build this for longevity so that it doesn't become the legacy thing in 5 years and people are screaming at it. So that's a challenge I think we all face, and I know my company does.
Yeah, have we built a throwaway culture these days, by and large?
Yes.
I think one of the challenges is going to be, you fortunately had Jimmy who had all this expertise with the system, but I was involved in a project to port some software to AIX and trying to find any experts that know about compilers and all, what word size to choose and all this kind of stuff. It's impossible because, well, IBM has basically let almost everyone go that works on AIX, right? And so how can we, get this knowledge out of people's heads, published on the internet or whatever, so future generations who have to deal with systems like this at least have some kind of reference for tips and tricks or what to do or where to look when dealing with this kind of stuff.
Our VAX experts are shy today. Please join us if you have anything to contribute to the conversation. We'd love to hear from you. I don't have anything right now. Oh, okay. All right.
But actually, I guess I do. So I was fascinated to see that you folks actually pulled this off, because this was a scheme that we had pitched for a completely different platform and a completely different application, and we were unable to get executives to buy in on it. They said, no, we'll just rewrite the whole thing in Java, and so instead the company went out of business. But when you're dealing with these multi-million line code bases that have a huge amount of domain expertise encoded into them and so on, has anyone else done or heard about a similar kind of effort, going through and actually working?
I think we do this on a regular basis. Everyone in the room, like, who's worked in a monolith that's decomposing into microservices, right? The scale of the problem changes and the fear factor changes as knowledge goes out, but the problem's ultimately the same, where organically evolved entrenchment of business knowledge becomes lost to time, and someone has to threaten that sort of like value line for the business, right? But I think we're engaged in it all the time. I don't know. I'd be curious to know, like, what's a reasonable lifetime for technology at the moment? It seems to be like there's an attitude that maybe software has become a throwaway culture, and that's a pejorative description. But like, what is a good lifetime now? Like, I'm curious as a person in the business, like, where do I make a good investment? Is it like 18 months? Is it 2 years? Is it 5 years? Like staff turnover. I don't know. A bunch of things contribute to it, but yeah.
Yeah, speaking as an operations guy, right, the lifespan depends partially on how much effort we as operations people are worth putting into it. I completely agree with your monolith comment, right? Like, we've got a big monolith of code that is going to be deprecated soon. So my argument, for the last 6 months has been around, look, if soon is, this is not the real number, 18 months from now, then it is absolutely worth one of my engineers putting in the time necessary to automate the deployments, to build a fake blue-green thing, to get the sort of incremental achievements as we can, because overall I can show you the numbers that says that's going to reduce the burden on the team and make it more reliable for the users. But because it's really, like you guys said, that doing VAX CICD, that's a great example. It's the effort you put into it and the effort making your software more reliable, more resilient, all those other good SRE buzzwords. That's effort that reduces the overall work for like 10 years, right? That's what makes our stuff reliable, not only in terms of how it's running in production, but durable in terms of how long can it run with relatively minimal effort. And I think we should be building for the 10-year, 20-year future, right? Like, our stuff matters. We should care about our stuff.
So one of the case studies on the continuous delivery website in the evidence and case studies section is about doing CD on AS400 mainframe systems. And again, you know, that people were like, oh, you can't do this, and they did do it. They wrote a little open source driver that drove the mainframe system through the VT and wrote a Java API for that, so they could write a bunch of acceptance tests that talked to the mainframe system through VT, and built this really comprehensive automated testing system. And this was in Suncorp in Australia. So Suncorp is Australia's biggest insurance company that acquired about 18 different mainframe systems through a bunch of business acquisitions, and they were trying to get it down to like a manageable 3 or 4. And obviously, you know, this is AS400, so it's a spring chicken compared to VAX. But you know, they managed to achieve similar results. I went there a year ago to see how they were doing, amongst other things, and they still use this automated test framework, and they say it makes releases much more reliable. They're much happier with it. They can get releases out much more frequently. They said the hardest part was convincing the mainframe people to give them a development instance so that they could actually build the tool chain around it, because they like didn't want to give their resources to anyone else. It's ours, you can't have it.
Say it's 400, so they couldn't be using Hercules, but I've had teams at ING in the Netherlands who used Hercules to actually emulate their real mainframes and do CICD on them.
Those are successes that we've seen in that area. Sorry, go ahead, Sasha.
So I'm going to bring it back to something that Cut talks about a lot. I think we're losing empathy for the developers and the technologists that are implementing technology, right? And we're just, I see a lot of consultants and various, you know, like sales engineers and stuff walking into rooms and saying your technology is all crap, you know, you should move on, like this is outdated. Well, you know, people make decisions for reasons that are valid in that particular moment in time, and not everybody has millions of dollars to keep throwing into technology, and realistically you have to keep old systems alive.
That's actually what a mainframe costs.
Yeah. Well, so I think we have to start also thinking about how humans work, and the fact that we can't keep learning and keeping up with all of this barrage of new technology that keeps coming at us.
There's a term for that. No? The dull stack engineer. A dull stack engineer. Google it, it's a talk I gave at some DevOps Days years ago.
So maybe the counter-argument to this approach, though, is whether the dev team has and continues to have critical mass on being able to support this technology, you know, another 20 years on the same code base. You know, do you on your team have the right bench depth to, you know, to say, yeah, not only do we have these people who've been here 30 years, but in the same amount of time, this will still be core to the business?
Yeah, I was complaining to my mom that I'm hiring, I can't find the right person, and she's like, have you tried a nursing home? And I'm like, I hate you. Yeah, so obviously there are only so many people, right, that know VAX Assembly anymore, but we are rewriting certain functionality in Rust, and not because we're like, oh, VAX Assembly sucks, but Rust just, it is right. You know what I mean? It's not because we just need access to new developers, but it's the right thing to do, and luckily the Rust community is awesome and does have a bunch of great developers in it, but yeah, we totally know. But also, I think in our corner of the Ticketmaster world, under our SVP, he definitely has the mindset that anyone can learn anything. And so, every year we have a bunch of interns in my team working on the VAX. And so I guess he just appreciates that anyone can learn anything if there's value in learning it, or even if just the value is my own fascination with it.
I want to say another thing, and that is bringing to successes. I think a lot of times people assume that they can't talk about their technology implementation unless it's really cool and overhyped. And that's why I really appreciate Kat coming here and giving the talk, because I really do see this. Like, people think they can only talk about Kubernetes today. Like, Docker is not cool anymore. Like, you know what I mean? Like, people move on and assume that what they're accomplishing in their organization is not cool enough to be on stage to talk about.
We'd love to hear about things that you've done that are not cool in your organization that have brought success.
Well, we had a very old legacy system that was delivered on an old school Apache web server. The thing was a large monolith. It carried a critical business function in the company, and we Dockerized the sucker and shoved it on a Kubernetes cluster. The Dockerization allowed us to stabilize what it did. And so, yes, we built, it was like a 34 gigabyte Docker image and shoved it on this this cluster and let it run. You know, the SREs at first were kind of like, what are you doing? But eventually they realized, well, this makes sense because now we've got control. It's in a harness and we could test it and so forth. So that's a success of blending the old with the new to take advantage of what's going on and go to those operational characteristics. How do we lock this thing down so that it operates in a certain way as opposed to this thing that we can't control? That was very successful with legacy technology.
Speaking of things that are not cool, but successful, in my experience, it was like architectural decision records, like just adopting a practice in the team of like recording when we made decisions so that they could be referenced by us, by ourselves, by somebody else. And that sort of like, the only way that I could convince people to do it was by sharing like, here's how this has screwed me in the past. By not having this, you know, I've cursed at myself, you know, unknowingly. I've been frustrated by inheriting technology that didn't make sense to me because I didn't understand the context. And so I think describing like how liberating it is to just say like, I'm making this decision under these circumstances and end of story, like this is how you can understand me 6 months from now, 10 years from now, and I don't have to worry about being crapped on as an idiot under, you know, a modern context that has nothing to do with the situation under which I'm making the decision.
Yeah, just going on the theme of things that aren't cool, but I think they're cool, is I work for a bank, and our mainframe, we started working with that team this year. And one of the cool things we saw is that we started working with them to change their working practices. We made no technology changes, and the team's confidence level to actually go to community of practices and actually talk about what they were facing and the challenges, and actually being like, oh, actually, we're not that different. And now they're actually a lot more confident to like challenge and contribute back to everyone else, because they just thought, oh, well, we're the mainframe. We can't talk about this, we suck. But actually, they realized they're just like everyone else, they just have a different technology stack.
Hey, so since we're talking about uncool things, I'm just going to share my uncool thing experience. So like one of my first jobs out of college, we got a massive desktop software thrown at us that was written in Delphi. Pascal-ish, you know, kind of. So the thing was just a piling heap of junk. It had no test written whatsoever. There was no confidence that when they built and released this thing out that it was going to work. And it was an additional struggle because when they released it out, it was for a bunch of oil field workers. So they'd get it out to them on the rig somehow, and these guys, you know, they don't know computers at all. They're just typing stuff into forms, trying to get it to work. It was crashing. They get angry phone calls from these, you know, blue-collar guys, and, you know, it wasn't pretty. And so none of the testing tools that we were choosing, the automated testing frameworks, worked natively out of the box with this software. So it was literally like, I'm gonna type into this text box, and I'm gonna start hitting like manual, like tabbing through the fields, inserting data into each one. So just working at it from a very like stupid interface. You had no native integration from your testing tool, your automated testing tools into the forms at all. So it was just like clicking on this XY coordinate on the screen, typing stuff in, tabbing the whole way through, and if nothing crashed, that was great. And eventually we got to the point where the software was stable enough, we had like a reasonable amount of confidence that we were shipping something out, it wasn't going to crash. It was just a huge win, even though it was a, you know, steaming pile of crap.
Awesome, thanks. I smell a theme of continuity, of connecting the past to the future with tools like Docker and Basil, and connecting the future to the past with architectural decision records and writing things down. I'll take one more comment here, and then we should quickly grab our last discussion topic.
So I don't want this to turn entirely into no shit, there we were. But my first job out of college was in writing Perl on the tandem. Anyone? Oh God, we have a winner. Yeah, so this is where the joke about well, it isn't back in our day, right? We actually ended up writing a web server in COBOL. And the reason was that was what actually let us take this system and glue it together with modern technology. You have something that wants to be able to do an RPC call. Turns out that web is fantastic for that. If you can turn it into a curl post on a shell escape, then now your databases are talking and you're back in business.
Real quick follow-up. There was just an article on Hacker News a couple weeks ago talking about writing a Slack client on Windows 3.1.1. And they had to do a lot of the same stuff you did, just described, yeah. Cool.
I just wanted to add that I learned Perl this year. It's my new programming language, and it's going great, so.
Fantastic. We have just a minute or so left. We have a speculative question that you've heard before today. What do you want to see in 2 to 5 years? What does it look like to continue to evolve these legacy and antique systems?
I think to me it's not about technology at all. It's about empathy. So let's have empathy for each other in this field.
Amen.
Thank you. And I thought Kat brought up a point, respect history. So respecting the history of where we've come and recognize there's a lot of great engineering that we can leverage. If you look back at CICS with, you post a record of data into a system and it gives you a response, like CICS was the original curl post response, and recognize that the engineering that was done then is what we can reapply now. And Sabre was a work of art, a massive piece of engineering when in the 1960s, and we can leverage that if we just remember it was there. So if you respect history, you're moving forward.
Also, more talks by Jimmy.
Yeah, I also want to continue that theme. One of the comments that the team at Suncorp made was that they don't want to call it legacy. It's like perfectly working systems that deliver business value. Those systems work just great. I remember talking to Rosalind Radcliffe, and there's some talk about distributed systems. She's a distinguished engineer at IBM. She's like, imagine if you could have a distributed system but with no network partitions. It's called a mainframe. And yeah, like these systems, I think legacy is kind of a misnomer.
Fantastic. That's the time that we have for this session. Thank you all so very much for listening to Kat and Jimmy and for participating in our discussion. We really appreciate it. Thank you.